Oh, okay. We're doing 1-3 line segments today. So our goal is to calculate the measures of line segments and apply the definition of congruent line segments to find missing values. We're going to be learning about that word congruent also today. Okay, betweenness of points. A line segment is a measurable part of a line. It consists of 2 points, called endpoints, and all of the points in between them. The 2 endpoints are used to name the segment. So for any 2 real numbers, a and b, there's a real number between a and b such that a is less than n is less than b. This relationship also applies to points on a line and is called betweenness of points. That's a weird concept, but what it means is that if there is a point between 2 other points, so let me draw this. Let's see here. So if you've got point A right here and point B right here, and they are part of a greater line, of course, but we're just going to look at them. This then becomes what we call a line segment. Okay? All right. And point C is between A and B if and only if they are collinear and if AC plus CB equals AB. So what that means is, I'm going to put C right here. If the distance from A to C, let's say this is 3 units, and C to B is, let's say it's 6 units. Well then, how much should A to B be? Well, you guys all know it. You know that the whole distance from here to here should be 9, because 3 plus 6 should equal 9. Well, you can do that in your head. No problem. You have no issue doing that. But what we do formally in geometry is we write that a lot more formally. We say that AC plus CB equals AB. Now remember in the last lesson where I said we take those arrows off at some point? Well, number one, these aren't lines, they're segments. Well, segments get different nomenclature. They get actually named this way. And we take the symbols off when we start putting them into mathematical equations, okay? We just name them straight out with the 2 points. And we write them out formally because then we want to start putting in the numbers for them. We say, hey, A to C is actually this 3. So we're going to put in 3 for it. And then, oh, and Mrs. Cruz wrote this one wrong. It's supposed to be C to B right here. My bad. I apologize, guys. And then C to B is 6. And then AB is the entire thing right there. So we should be coloring all of these up. There we go. There we go. 9. Yep. And obviously you're probably not going to do that for a really easy equation like this. But the equations don't stay easy in geometry. So being able to write them out formally like this will help you get to this equation at the end. Okay. So here we go. Here's a pretty basic example. What's the measure of x to z from here to here? So if we were to write that out formally, we would say, well, that's going to be xy plus yz. That will be what xz is. And then we do substitution. We say xy is actually 11.3. We substitute in the right value. And yz is 3.8. And that would be, let's see, 3.8 plus 11.3 3. Well, 3 plus 8, that's going to go up to 1. 4, it's going to be 15.1. There we go, 15.1. Now, if you haven't already, I love this app right here as my calculator app. It works really well, and it hides off to the side nicely there. So the Calc 84 app, Calc 84. Okay, so there it is. So, and this is what we call a proof. And we're going to be using proofs in ALEKS a lot. So it's good to start seeing those. Let's say, and they call this the betweenness of points in McGraw-Hill. But let's see here. I'm going to call this what it truly is. This is segment addition. Segment addition. And then we substitute in its values, and then we simplify our equation. Okay. There we go. All right. Now it gets a little bit more difficult. Now we get some fractions there, and definitely fractions are going to happen a lot in ALEKS because they want to keep our brain nice and sharp, okay? So we would do the same thing. We would say DE plus EF. Oh, this is your practice. You get to go do that. So go practice that, pause it, and then come back for the answer. Did you get 8 3/5? I hope so. Okay. Now your next one is going to be subtracting. We set it up the same way. We say PQ plus QR equals PR. And when we substitute in, we get 6 5/8 plus QR equals 13 3/4. And now we have to minus our 6 5/8. And we get QR equals this right here, which is 7 1/8. There you go. Feet. Don't forget our units there, Mrs. Cruz. Okay. So go ahead and practice that. And they give you a nice decimal there with centimeters for your practice. Pause me if you need to. There we go. Did you get 6.5? I hope so. Now, this one. Here's a practice for you. Right before you pause, notice they did not give you a diagram. That's okay. Draw one yourself. Every time you get something without a diagram in geometry, draw it. So they tell you, find the value of x and BC if B is between AC. So go ahead and draw A to C and draw B somewhere in the middle. And I would really recommend you not draw B exactly in the middle because our brains are wired to see midpoints and you'll start thinking that it's exactly in the middle. So don't do that. And then start putting in exactly what you see. 2x plus 3. And then that from here to here is 4x minus 12. Okay? So draw yourself a diagram. Now pause, solve it. Okay. If you're struggling, if you've come back here, you're struggling, there we go. Got some just our diagram and write out your equation. Just plug those in and solve for x. And did you solve and find that x is 15? And then when you solve for x, did you plug x in to find BC? And do your answers make sense? Like when you solve for them, did you get something negative? Did you get something wonky? Like always use your common sense double check. Like, did my answer make sense? Okay. And hey, once you found BC, how could you find AC without plugging it in? Was there another way? We'll pause and think about that. Okay. Now, try this one. Go pause and try this practice. And did you get that answer, 520? If not, try it again. Work it out. All right. If two geometric figures have exactly the same shape and size, then they are congruent. Okay? Congruent and equal feel the same. Okay? But this one is talking about equations. This one is talking about properties, shape, size, okay? Okay, so they're not exactly the same word. The funny thing is they look really, really similar. Okay? So, you know, how do I say that? Let's show you. Here we go. Congruent segments. And in your notes, they say congruent line segments. But here's the symbol for it. It looks like an equal sign, but it's got this weird little flick over the top of it. Looks like a sideways S. Okay? And we read it is congruent to. So red slashes on the figure. Okay, let's see here. What do I want to say next? Yeah. So if we're looking at these figures over here, we'd say, hey, AB and CD, those two line segments, they're both 1.7 centimeters. So they have the same size. They have the same length. So that means they're congruent. So we would write them out like this. Line segment AB is congruent to line segment CD, meaning they have the same properties. They are the same length. Okay? And we would read them out that. We would say segment AB is congruent to segment CD. We would write it out exactly like that. Okay? They have the same measure. That's how we would talk about them. The funny thing is we could also write AB is equal to CD, because equation-wise, they have equal number, if that makes sense, when we're putting them into an equation. So again, when we're talking properties, they're congruent. And we're talking equations, look how they lose the segment notation for equations. get really small in there. Sorry, guys. Okay. So that gets a little funky. A weird distinction, okay? And you see that happening over here in this example. See, we say PQ is congruent to QR, and we keep that segment notation on top. But then up here we say PQ is equal to 6x plus 20. Since we have an equal sign, there's no segment symbol on top. Equal means we're talking equations, we're talking about numbers, we're talking about something that can go into an equation. So, difference. Okay, and now the last thing I want to point out that I didn't yet, we're going to come back to this slide here. These symbols right here, really cool symbols. I'm going to get my pink sign out because I really love them. These little dashes on here, they're called congruent marks, okay? We write them in different ways, but let's say, I'm gonna make kind of a complex diagram. Let's see, we've got a line, oh, nope. You don't have to write this. I'm going to do some other things here, okay. And then I'm gonna grab a little red one, okay. I'm going to say that this segment here is congruent to this segment here. This one in here, see how I'm going to put 2 marks, is congruent to this one in here. This guy in here is congruent to this guy in here. Oops, we're starting to get really small. I think I'm good there. Okay. Notice I keep adding hash marks, because I want to be very clear on which is congruent to which. So I'm not going to put singles for all of them, but it's kind of like a game of matching. So these ones match together, these ones match together, and these ones match together. That's how those congruent marks work. They also work the same way for angles. So when we get into angles, which we're not doing today, but when we've got like an angle over here, and an angle down here. And we want to show you that they are congruent. We might mark this one and this one congruent by putting a swoop. That's a way to show that they're congruent. Or you'd put 2 congruent marks. Some people also mark them this way. They put that with a hash, and I'm like that way. I don't prefer that way, but you will see that notation. So it's not a big deal either way. Okay, so those are different congruent marks you can see. That's that red slashes. They don't have to be in red. You can do them in black. That's fine. But all right. So example, find the value if Q is between P and R, and they're giving some numbers here. Oh, and they tell you that they are congruent. Okay, if we know that they're congruent, that means that PQ is equal to QR, which means that 6x plus 20 must be equal to 2 times x plus 6. And then that's just an algebraic equation that you get to solve. And you've got a few different ways that you can do that. You can distribute your 2. Lots of people love doing that. You could also divide both sides by 2. That's up to you. Since most people love distributing 2's, we're going to do that. 6x plus 20 equals 2x plus 12. And then I am going to, let's see, oh, where am I at? Grab my red, and I'm going to subtract my 2x from both sides and end up with a 4x plus 20 equals 12. And then I'm going to subtract my 20 from both sides and end up with a 4x equals negative 8. And divide by 4. And end up with an x equals negative 2. And you might freak out at this point because can an x be negative? Ooh, that feels a little freaky. X's can be negative. They really can. But you need to double check to make sure that it's like that makes sense, okay? Do a common sense check. So let's go plug it up in there. So if I plug in a -2 up here, so 6 times -2 plus 20, I end up with, let's see, -12 plus 20, which means that this is 8. And if I put in a 2 times -2 plus 6, that would be -2 plus 6 is 4. 2 times 4 is 8. That makes sense. They're both 8. So this is an okay answer. Okay? Find the value of x. X is -2. Gonna go check it out. It's good. All right. Now you go do the practice. Pause me. Go work. All right. And you should have gotten -7, 3.